Welcome back to NCERT Class 9, Chapter number 8, Motion. Children, after learning Motion chapter and also solving the numericals, that is in-text problems of it, in today's class, we are discussing about that is exercise problems of a Motion chapter. In this class, I will help you to understand the exercise problems of a Motion chapter. Is it, children, understood what we are going to discuss in today's class? We are trying to solve few more numericals on Motion chapter. By yesterday's or the previous video, we have completed all in-text problems, how to solve all such things came to know, I hope. Isn't it, children? So, in today's class, we are going to learn how to solve the exercise problems. Okay. First question, that is from page number 112, children. These are all today what we are discussing now, which are all related to exercise questions. In that, question number 1. Even you can note it down. Page number 112. This is what page number. What is the first question? An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of a 2 minutes 20 seconds? So, children, here an athlete is making a complete one round. Means this circular round he is making. Means this path he is completing. Let us assume this is what initial point, isn't it? And the diameter, sorry, and this is what B. And what is this length, children? That is diameter has given what? 200 meter. And in how much time he is completing one round? That is, for one round he is taking 40 seconds of time. Isn't it, children? How much he is taking? 40 seconds of a time. This is. So, our question is, means what we need to solve means distance and displacement at the end of 2 minutes 20 seconds we have to calculate. Understood, children? So, at the end of 2 minutes 20 seconds we need to calculate that is what? Distance and displacement. Isn't it? This is what question. What they have given? They told that an athlete is making a round on the circular path from position A to B, which is having a diameter of a length 200 meter, and to complete this one round he is taking a 40 seconds of a time. And we need to calculate the distance and the displacement at the end of what? 2 minutes and 20 seconds. So, if one round he will take 40 seconds means, let us calculate at the end, means this is the time. That is total or time taken at the end. How much, children? 2 minutes 20 seconds. So, we need to convert it into seconds now. Yes. 2 into 60 and another 20 seconds. Which means how much, children? 120 plus 20, 140 seconds. So, the total time he has taken to complete, that is at the end of 146 seconds, how many rounds he has completed, we need to know. By doing so, we will get the values of a distance and a displacement. Is it understand, children? Okay. So, in 40 seconds, if he completes one round means, in 140 seconds, how many rounds he'll make? So, that is what? 1 by 40 into 140, 0 get cancel, 4 1s are, then 4 3s are, then 0.5, isn't it? So, 3.5 rounds he will make nearly. So, at the end, how many rounds he is completing, children? Like this, one time he will complete, and once again 2 times, then 3 times, and half round he will complete by what? At the time of 3.5 rounds, he will complete by 2 minutes 20 seconds. And here they has given diameter, children. Diameter of the circular track they has given. We know that the radius is nothing but a half of its diameter. Isn't it, children? So, how can we write now? R is equals to 200 divided by 2, which is nothing but a 100 meter is the radius. Because in order to find the circumference of the circle, when we will use a 2 pi r, at that time we need to know what radius. So this is what radius. And what is the circumference of the circle formula, children? That is 2 pi r into how many rounds? This is what distance, isn't it? So distance is what? 2 pi r, because circumference of the circle into how many rounds he'll make? 3.5. Now substitute the values. 2 pi r. Pi means pi value we already know, 22 by 7. Radius 100 into this 3.5 can be written as a 35 by 10. Isn't it, children? So now cancel these. This one 0, this one 0 get cancelled. 7 1 ja, 7 5 ja. What is left? That is 2 into 22. Directly you can write this as a 44 into 50. 10 into 5. 50. Is it clear, children? Okay. Then 2200 meters is the distance. What is the distance, children? 2000. Yes, 2200 meter. Distance is how much? 2200 meter. So, one part of the problem we have completed. So, the next part is what we need to calculate the displacement. Isn't it, children? So, what is the meaning of a displacement here? This is nothing but a shortest path we need to calculate. So, at 40 seconds, he is making one round, isn't it? And in 80 seconds, he'll complete second round, isn't it? At 80 seconds, he'll complete second round. And similarly, at 120 seconds, he'll complete third round. So, another how much seconds left, children? 20 seconds. He will complete half round, which is nothing but a from A to B Helmholtz. Isn't it, children? So, at this moment, where he stopped, no, this is a final position. This final point is opposite to the initial point A, diametrically, which is what? Opposite. So, hence, we can take the displacement as a diameter value. The second one, what? Displacement is what? 200 meter, because diametrically it is opposite. The end point, final point is diametrically opposite to the what? Initial point. Hence, we will get the same 200 meter. That is whatever the diameter we have now, that only we will get. Is it clear, children? Okay, let me explain once again, children. The question is simple. An athlete is making a one round, means round is nothing but a circular path. It have a radius and also diameter. Always diameter is nothing but a what? Half of the, so yes, radius is nothing but a half of its diameter. And if he completes for one round in 40 seconds, means at the end of 2 minutes 20 seconds, what is the distance and displacement? So, in order to do that, first we need to calculate total time taken. The total time taken, how we will calculate? That is, we will convert it. Minutes means 60. Then another 20 seconds we will add. We will get 140 seconds is the total time taken here. Isn't it, children? So, and with this help, that is circumference of a circle formula. After applying that, for 3.5 rounds, we will get distance 2200 meter. And the displacement is what? At the end, means 3.5 rounds. At this point, it is opposite to the initial point. So, what the displacement we will get? That is 200 meter. Is it clear, children? Now, we will solve the second question. What is the, children? Joseph jogs from one end A to the other end of a straight 300 meter road in 2 minutes 30 seconds, and then he returns or turns around and jogs 100 meter back to a point C in another 1 minute. What are the Joseph's average speed and average velocities in jogging from A to B and from A to C? See, children, whenever they'll ask speed, average speed means directly we will go total distance and a total time taken. Here, this is what different, children. First, we need to do bit by bit. Means first from A to C. For example, Joseph is making a jog from point, what is that, children? From point A to B he goes. Up to this, how much distance is there? 300 meter. Isn't it, children? So, first time what he will go? He will travels from point A to point B. At what amount of a time? That is at 2 minutes 30 seconds. Isn't it, children? And then he returns around and jogs. Returns means, he turns means he moves back. At this point, let us say, we'll name this as a C, which is of a 100 meter. This is what? 100 meter distance he'll cover. In how much time? That is in another, at 1 more minute he will take. Isn't it? So, for this, we need to calculate first one from A to B. Average speed and average velocities we have to calculate. So, first, children, we will calculate of first one, that is from A to B. In order to calculate average speed, we want a total distance. Isn't it, children? The total distance, how much he will cover from A to B? That is 300 meters. AB is equals to what? 300 meters. Similarly, total time taken, how much? Time taken, T is equals to what? 2 minutes 30 seconds. It means that 2 into 60 plus 30, which is equals to 120 plus 30. How much, children? 150 seconds. So, what is the total distance? 300 meter in 150 seconds he will do. For this, we have to calculate average speed, children, which is equals to total distance divided by total time taken. This is what formula. Now, substitute, children. In short, we can write it as a AVG speed, nothing but a average speed, which is equals to total distance. How much? That is 300 meter plus divided by total time taken, 150 seconds. Isn't it? So, 0, 0 get cancelled. 5 3s are 5 6s are 3 1s are 3 2s are. How much left, children? 2 meter per second. So, what is this average speed? 2 meter per second. And next, what we have to calculate? That is average velocity. Average velocity. So, what is the formula of average velocity, children? Total displacement divided by total time taken. Total displacement divided by total time taken. So, average velocity from A to B. So B is equals to, what is the total displacement? The shortest path. See here, distance and the displacement are same. So the same value will get it as a what? Distance, that is 300 meter. Divided by, what is the total time taken? 150 seconds, which is equals to the same 2 meter per second you will get. Is it clear? This is what first question we have solved. First part of the question we have solved. And the next we have here, look at children, also calculate from A to C. Isn't it children? What we have to calculate another part, that is what? Yes, from B is what? This is A and this is what? B. From A to C. First, in the same way children, first calculate total distance. Total distance, which is equals to total distance. First, how we will go children? AB he will go, from A to B he will go, then B to C he will return. So the total distance is what? AB plus BC, which is equals to 300. What is the BC value children? 100, which is equals to 400 meters. Similarly, total displacement. First he will move from A to B minus BC. Isn't it children? So you will get 300 minus 100, which is equals to 200 meters is the total displacement. Okay. Now for this calculate average speed, which is equals to total distance divided by total time taken, which is equals to how much children? 400 divided by, what is the total time? Here, yes, total time is how much? The total time entirely he has taken 2 minutes 30 seconds plus 1 minute of a time. 2 minutes 30 seconds means 150 seconds plus 1 minute, nothing but a 60. So 150 plus 60, 220. 150 seconds plus 60, which is equals to 400 divided by 210 seconds. So average speed is equals to 400, no children? Yes, 0, 0 get cancelled. Then 21, yes, 40 divided by 21. Directly you can take 1s, isn't it? 21, isn't it? 21, that is 40. 21 2s are 42. It is not going so better. 1 only. 9, 3 minus 2, 1. Here let us take point, isn't it? Then 21 9s are 9, 9 2s are 18, isn't it? 1 0 point recurs. Then here once again 1.5 10. Yes, it won't goes 1.9, isn't it? What is that? 1.92 meter per second you may get. The next is what? Average velocity, which is equals to total displacement divided by total time. So what is the total displacement children? 200 divided by, what is the total time taken? 210. 0 0 cancelled. So once again, this is all rough work. Let us make 21 into 20. So small value, it won't goes. So 0.9, isn't it children? 0.92 meter per second is the average velocity. Average speed is what? 1.92 meter per second from A to C, and average velocity is what? 0.92 meter per second. So children, once again I'll explain. Here a Joseph, he is making a job from point A to point B and he will cover 300 meter distance. It is very much clear children. He will cover 300 meter distance and he'll take for that time 2 minutes 30 seconds. So next he'll moves back, that is he turns back towards A at a point C and he'll covers what 100 meter at another 1 more minute. So after applying average speed formula, that is total distance divided by total time taken, we will get both the values. That is from A to B, he will take average speed. His average speed is 2 meter per second and similarly his average velocity is also found to be same. And the next is from A to C, his total distance is what? 400 meter and total displacement is 200 meter and the total time taken, this plus this is the total time taken and we will get what? 210 seconds. So after substituting the values in this formula, we will get average speed 1.2 meter per second and average velocity what? 0.92 meter per second. Is it clear children? The question is of that. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is a less traffic and the average speed is what? 30 km per hour. What is the average speed for Abdul's trip? Let us make children, that is imagine this is a home. The person is what? Abdul. He is traveling from home to school, isn't it? This is what? School. He computes the average speed how much? He'll compute, that is average speed. Yes, which yes, he will do his speed is what? Not this is average speed, that is 20 km per hour and he will move once again back to the trip, means he'll go back from school to home. First he'll move from home to school, then he'll go from what in the second trip you can say, isn't it? He'll go from school to home and he'll take at this moment 30 km per hour, isn't it children? This is our question. For this we have to calculate average speed. Okay. So this is our question children. First, we don't know how much distance he has covered. So let us take, let x be the distance he covered. Distance he covered. Isn't it? Every time children, while calculating the average speed, we should know our total distance and our total time taken, isn't it? And the first one, that is time taken for, that is speed 20 km per hour. We don't know, isn't it children? That is can be taken as a, what is that? T1 is the time taken divided by distance divided by time taken. So speed here is what? 20. What is the distance? X. Here T1 is the time taken in order to complete his one trip. One side trip you can say. Let us say this is what? Equation 1. Means this T1 is nothing but a time taken in completing from, means in moving his journey from home to school you can say children. Okay. Next, he will take, that is time taken for speed 30 km per hour is what? T2. That is x by 30. This is what? Second equation. So in order to calculate average speed, first we should know total distance divided by total time taken. So here the total distance is what? He will cover x distance, then moves back to the same place. That is, he'll make another trip from school to home. So we will get the total distance is what? 2x. 2x is the total distance. This x, same length, no? X plus x, which gives us what? 2x. Then next is what? Total displacement. Sorry, displacement don't want, total time taken we want. Total time, which is what? T is equals to T1 plus T2. Isn't it, children? So this implies T is equals to, what is the T1? T1 is x divided by 20 plus x divided by 30. So what is the LCM, children? Here, which is equals to LCM is 60, isn't it? Then how much? 3x plus 2x, which is nothing but a 5x. So the total time is what? 5x divided by 60. Okay. Now, average speed is equals to total distance divided by total time, isn't it? The total distance is how much, children? Total distance is 2x. The total time is how much? 5x by 60. So this 60 goes to numerator, means what is that? 2x into 60 divided by 5x. Okay. Let us take the x common terms, that is 2 into 60 divided by, here also x in the denominator, 5 has left, x get cancelled, 5 ones are, yes, 5 ones are, then 5 twos are. So how much? That is what? 24. 12 into 2, which is equals to 24 kilometer per hour. This is what? His average speed. His average speed is how much, children? 24 kilometer per hour. Is it understand? Okay, once again I'll explain, children. First, here Abdul is moving from home to school. For that, he's moving with a speed 20 kilometer per hour. We don't know how much distance he has covered. So let us imagine or assume x be his distance what he covered. Okay. Now for that we need any average speed. We should take a total time, children, isn't it? So using the formula, what is that? Speed is equals to distance divided by time. In terms of a time, how we will write the formula? Time is equals to distance divided by speed. The distance is what here? X, and 20 is nothing but a here speed. This is, let us say, equation 1. And similarly, he moves from school to home, isn't it? Means another trip. This is his first trip or another trip from school to home, you can consider. At that time, he will get a T2. And the total distance he is making x plus x, and after applying all the substituting all values in this formula, you will get a average speed 24 kilometer per hour. Is it got understand, children? Okay. Next we will move with the fourth one. Children, the fourth question is of a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? It's a very simple, children. That is what is this question number? Fourth one. Here a motorboat. Let us imagine this motorboat is starting from rest. Let us say this is a point A which is at rest. Means at this moment his initial velocity will be 0 and he'll move what? Straight line with a constant what is that? Rate. Acceleration is how much? 3 meter per second square. For how much time will take? 8 seconds. Isn't it, children? 8 seconds he will take time. So how much for the boat will travel during this time? We need to calculate this distance. Isn't it, children? That is S we have to calculate. So which formula we have to use, children? that is S is equals to ut plus half at square, because we know given values are what? U is equals to initial velocity. It starts from rest, so ultimately what happens? Initial velocity will be 0. Then time is what? 8 seconds. Acceleration is 3 meter per second square. Okay. S we have to calculate. Distance, how much it has covered, we need to calculate. So now substitute, children, the given values. U is 0. T 8 plus half. What is the acceleration value? Into 3. 8 square, nothing but 8 square. 0 into 8, 0 plus half into 3 into 8 into 8 we can write, no? T square, nothing but 8 square you can write in this way. 2 1s are 2 4s are, isn't it? So what is that? 8 4s are 32. 32 into 3, which is nothing but 96 meter is the distance he has covered in 8 seconds of time when he moves with a 3 meter per second acceleration. If he moves with this acceleration, his distance will be what? 96 meter. Is it clear, children? It's a very simple. Here a motor boat starts from rest and it moves along the straight line with an acceleration of a 3.0 meter per second square, and it takes a time of 8 seconds. So since here U we know, T we know, and also acceleration A we know, we need to calculate its distance value. So which formula we have to use? The third equation, that is S equals to, second equation, S equals to ut plus half at square. Now substituting the values, we will get the distance covered is what? 96 meter. Is it clear, children? Okay. Now we will move with the fifth question. The fifth question. A driver of a car traveling at a 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. Means here one car is moving with a what? 52 km per hour and he applies what? Brakes. And the car stops in what? 5 seconds of a time. Another driver going with a speed what? 3 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars traveled further after the brakes were applied is the question. So children, in order to solve such a kind of problems, yes, first we need to know the first car value, isn't it, children? Let me take better. This has, you people has to do with the help of a graph sheets, children. So for first car, let us find for first car, initial velocity is what? 52 km per hour. So convert this into seconds, children. What is that? 52 into 1000 divided by, what is the time? 3600, which is found to be nearly 14.4 meter per second. So with this speed, the first car is moving. Isn't it? And he applies a brakes. Then its final velocity will be of what? 0, children. In how much amount of a time? That is in 5 seconds. He'll take for this what? 5 seconds. This is what the details of a first car. Similarly, do for the second one. That is for second car. His velocity is what? Initial velocity. How much? That is 34. See, children, it's a print mistake. Make it correction in your textbook. Fee of the textbook, we got a what? 3. So make it correction. It as a 34. That is actually 34. Okay. Then this also do same. Convert for seconds. 34 into 1000 divided by 3600, which is found to be nearly 9.4 meter per second. What is this? This is the initial speed. The car is moving with this speed, and at this moment once again the second car, means the second car also applies brakes, and its velocity becomes what? 0, final velocity, at which amount of a time? At 10 seconds of a time. Isn't it, children? This is our data. Now first we have to what? Plot these two given data on a graph sheets. See children, like this your graph may look, isn't it children? I will just show you in rough work how to draw on a graph paper. Let us take, this is the origin point, and 10 seconds is there now. Let us take 2, 4, 6, 8, 10, this side all. On x-axis you have to take time now, so we have taken time. On y-axis let us take speed, how much value? 14. So let us take this beta 4, then 8, yes, 12 and 16, means 14.4 somewhere you will get. In graph sheets you can take scales of your own choice children. Even you can take 1, 2, 3, 4 on y-axis. Similarly 1, 2, 3, 4 seconds on x-axis. Here space is short, so I am taking a rough work, that is nearly 4 units. We are taking it as a scale. Okay. Now for first one, isn't it? 14.4, its velocity will be what? 0. In how much seconds? In 5 seconds. Might be you will get here. A triangle you will get children, isn't it? We will name this as a AOAB, isn't it? Next, for second car, what is its speed? 9.4 seconds. Somewhere here you will get. And what is its time? 10. So you may get another triangle in this way. Let us name this as a C and D. For this we need to calculate the distance travelled children of two cars, and also we have to find which one is moving fast, isn't it? First, for distance of first car is found to be that is area of a triangle OAB children. That is triangle OAB. So what is the area of a triangle formula? Half into base into height, isn't it children? Now what is the base? Base is nothing but a time value. Nearly how much? That is 5 seconds. Height, what is the height? 14.4. So by doing this cancellation you will get 36 meter. And the second part is what? Similarly do for distance of a second car. Calculate distance of second car, which is equals to area for triangle OCD. OCD. Once again half into base into height. What is the base value children for second triangle? Yes, here 9.4 into time. Time is what? 10 seconds, isn't it? So you will get, which is equals to 47 meter. So here the first car is moving with a distance what? 36 meter, and the second car travels a distance of 47 meter. Is it clear children? And also the second car is, we can say that it is moving with more speed, you can say. Is it clear? Okay, once again I'll explain children. Here they has given two cars are moving with two different speeds. With this data they asked us to plot a graphs and calculate their distance is the question. So how we have to do? First we have to take its initial velocity and convert it into seconds. Then he is applying a brakes, no, then the car ultimately comes to rest. At that time velocity is what, speed becomes 0, and in time how much given, 5 seconds. Do for the same, and next plot the graphs by taking the given values or found values. You will get a distance as a 36 meter for first car and 47 meter for the second car. Is it clear, children? Okay. Children, sixth question, take it as a homework. It is a very easy. If you unable to solve that, definitely I will help you in the next class. Don't worry. Now let us move with the seventh question. That is what? A ball is gently dropped from a height of 20 meter. Let us imagine, children, here a ball is dropped from this point to ground, isn't it? What is this height, children? Which is 20 meter, nothing but a distance, isn't it, children? Height is nothing but a distance. So its velocity increases uniformly at the uniform increase in velocity is nothing but a acceleration, children. So acceleration is found to be 10 meter per second square. At this point, from this point, its initial velocity will be 0. We have to calculate v value and t value, isn't it, children? So first we'll calculate v. Which formula we have to use? V square is equals to u square plus 2as. Now v square is equals to 0 square plus 2 into 10. Then what is the distance? Nothing but a height, 20, isn't it, children? 0 square nothing but a 0 only, children. Then 2 into 10, 20, 20 into 20, 400, which is nothing but a square root of 400. You will get 20 meter per second, isn't it, children? The final velocity is what? 20 meter per second. For this formula, v is equals to u plus at, nothing but a t is equals to v minus u divided by a. So now substitute the values. What is the v value? 20 minus u 0 divided by 10, which is equals to 20 divided by 10. So what is the time, children? 10 ones are 10 2 seconds. Is it clear? Okay, and so I'll explain, children. A ball from certain height is left to the ground, means it is dropped to the ground. So at this point its initial velocity will be 0. First we have to calculate its final velocity, means what is its velocity when it has reached to the ground is the question. Nothing but a final velocity we have to calculate, and also the time value. Let us use the formula. Third equation, v square equals to u square plus 2as. Here substituting the given values, you will get a velocity 20 meter per second. The next, in order to calculate time, let us take the first equation, v equals to u plus at, which is what? Time you will get about 2 seconds. Is it clear, children? Okay, next we will move with the another one. Children, now we will solve, that is, children, now we will solve 10th question, that is, an artificial satellite is moving in a circular orbit of a radius 42,250 km. Calculate its speed if it takes 24 hours to revolve around the earth. So children, we learned that in order to calculate speed of an object, if it is moving in a circular path, can be given by the formula what, children? V is equals to 2 pi r divided by t. Isn't it, children? This is the formula. This is 10th question we are solving, that is speed of an object revolving around circular path, can be given by the formula V is equals to 2 pi r divided by t, isn't it? This is what formula. We have discussed this in the uniform circular motion, isn't it, children? So now with this formula, what are the given data, children? The radius is how much? 42,250 km. 42,250 km, and the time is what? 24 hours. First we will do with the what? Kilometer per hour, children. So the circular path, that is nothing but a circumference of the circle's formula all we have derived, isn't it, children? So now substitute the values. V is equals to 2 into, what is the pi value? 22 by 7 into, what is the radius? Radius is 42,250, isn't it? Divided by, now what is the time, children? 24, which is equals to, what is that? 2 into 22 into 42,250 divided by 7 into 24. When you do cancellation of all these, you will get nearly 11,065.4 kilometer per hour you will get, children. What is the speed you will get? V is equals to 11,065.4 kilometer per hour you will get. Directly I did, children, because it's a big, you can do on your own multiplication, okay, of too many digits, nothing but a 4, more than 4 is there, so you do directly. Then yes, since it is in kilometer per hour, we have to convert that for into seconds, isn't it, children? So now V is equals to 11,065.4 divided by, in 1 hour how many seconds? 3,600 seconds. So after doing cancellation, you will get nearly 3.07 kilometers per second, isn't it, children? So what is the value of our speed, children? V is equals to 3.07 kilometer per second. Got it, children? Okay. See, children, this question is a very simple. If you understand the question neatly, here they clearly said that an object is making a circular path and its radius is found to be 42,250 kilometer and duration is over here 24 hours. So by substituting all the values, you will get in terms of a seconds what? 3.07. In terms of a hour means you will get 11,065.4. Got it, children? Okay. Practice all the problems 2 to 3 times until you are perfect with those. Thank you.